Hi everyone, welcome back to an advanced higher stats lesson. This lesson we are looking at discrete random variables. You'll find this skill on page 20 of the 2023 Advanced Higher Course Pack. By the end of this lesson, you should be able to draw a probability distribution of a discrete random variable. You should be able to calculate the expected value, variance, and standard deviation of discrete random variables. You should be able to use the following formulae. You should be able to calculate k and find the probability of x equaling a value, and you should be able to compare experimental probability distributions and theoretical probability distributions. To recap, a discrete variable is a variable that can be counted, like the number of students in a class, and mostly take form of whole numbers or integers. A random discrete variable, an example of this, is a singular dice roll, because every possible outcome is random. Now let's draw the probability distribution of a singular dice roll. We'll use x to show all the outcomes. So 1, 2, 3, 4, 5, 6. And we'll use the bottom row to write the probability of getting those outcomes. If we assume that this is a fair dice, every probability is 1 out of 6. And how we show that is by writing the probability of lowercase x, or the actual outcome of the dice, equaling large X, the number at the top here. Questions involving discrete random variables often ask for these four things: E of x, which is the mean or the average; V of x, which is the variance; sigma, which is the standard deviation; and also k, but we'll look at that later. Now let's try this question and try and find E of x. A coin is flipped 3 times and the outcome is noted. Let x be the number of heads achieved in these 3 attempts. Find E of x. So the first thing we do here is we draw our probability distribution. So we have the outcome 0, 1, 2, 3. And now we need to find the probability of these outcomes. So first, let's see how many different combinations of heads and tails we have. So each coin flip has 2 possible outcomes. And since we're doing it 3 times, we do 2 to the power of 3, which gives us 8. So there are 8 possible combinations of heads and tails that we can get. Now let's start from 0. How many ways can we have 0 heads? Just one. We can have tails, tails, tails. So that means the probability of getting 0 heads is 1 out of 8. Now the probability of getting 1 head, let's write down the combinations. We can have heads, tails, 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 heads, tails, 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 heads. So that gives us 3 out of 8. Now the same thing for 2 heads. We can have 2 heads and a tail. We can have head, tail, head. And we could have tail and then 2 heads. So that's also 3 out of 8. So that must mean this is 1 out of 8. Okay, so we have the probabilities. Now what do we do? Well, we need to find out the expected value. And we do this by timesing x by the probability of that x happening, and we add them all together. So how this would work out is 0 times 1 over 8, which is 0, but we'll include it for understanding. 1 times 3 over 8 plus 2 times 3 over 8 plus 3 times 1 over 8. And that gives us 1.5, which is the expected value. Now, often in these questions, after you find E of x, you have to find V of x and sigma. So let's do that for this question. So to find V of x, we need to use the formula V of x is equal to E of x squared minus e of x all squared. Now we have e of x, but we don't have e of x squared. So we can replace this with 1.5 squared. But how do we find e of x squared? Well, how we found e of x was adding all the x values, well, timesing all the x values with their probability. So to find the expected value of e of x squared, we times all the x squared values with the probabilities. So let's get the x squared values. We have, well, 0 squared is 0, 1 squared is still 1, 2 squared is 4, and 3 squared is 9. So that means if we want to find e of x squared, it is, first it's 0 times 1 over 8 plus 1 times 3 over 8 plus 4, not 2, 4 times 3 over 8 plus 9 times 1 over 8. And that gives us 3. So now we have e of x squared, and we can input this into the formula. 3 minus 1.5 squared is the same as 3 minus 2.5, which gives us 0.75. And the next part of this question is hence find sigma. And before we hinted at the relationship between variance and sigma, and that is very simple. It's basically v of x, or variance in general, is sigma squared. So to find sigma, sigma squared is 0.75. That means sigma is root 0.75, which gives us 0.866. Now, using what you've learned, try and do the following question by yourself. In a deck of cards, 52, 4 cards are drawn. Let x be the number of kings in the hand, draw the probability distribution of x, and find x. Here we are given the combination of possible hands, whereas before we had to calculate it. This is just to make it a bit simple. The first thing we do is we draw the probability distribution, and let's start off with the values of x. So x can be either 1, well, let's have a 0, x can have 0 kings, 1 king, 2 kings, 3 kings, and 4 kings. Now, we need to find the probability of that being the case. Whoops. Okay, so let's skip 0 for now, and let's go for 1. How many different ways can we have 1 king in our hand? Well, we can have the king of hearts once, we can have the king of diamonds, the king of clubs, and the king of spades. That's 4 different hands out of the total 27725. Now, how many ways can we have 2 kings in our hand? We can have hearts and diamonds, we can have hearts and clubs, we can have hearts and spades, we can have diamonds and clubs, we can have diamonds and spades, and we can have spades and clubs. So that gives us 6 out of the total number of combinations, 270,725. Same thing for 3. How many different ways can we have 3 kings? So hearts, diamonds, clubs, heart, diamond, spades, diamond, club, spades, heart, clubs, and spades. That's 4. 4 out of the total. And how many ways can we have 4 kings? Well, that is simple. That's just 1. Heart, diamond, club, and spades. That's 1 out of 270,725. Now, if we just do 1 minus all of these probabilities, we'll get the probability for x being 0. So what we're doing here, basically, we're doing 1 minus 15 over the total. And that gives us, with my calculator, I got a decimal, but it is 0.9999. So most of the time, you won't have any kings in a 4-card hand if you have 52 cards in total. But the question was finding E of x. And we do what we did the last question. It's 0 times 0.9999, which I can skip now because we've already covered it, but I've included it, plus 1 times 4 over that, plus 2 times 6 over that, plus 3 times 4 over that, and plus 4 times 1 over 270,725. And that gives us a number which is 0.0001. I realized here I wrote the denominator wrong, so apologies for that. Now try and find variance and sigma by yourself. Okay, so the first thing we do is write the formula, which is v of x is equal to e of x squared minus e of x all squared. For e of x squared, we need values of x squared, which I will write here. So 0 to 1, 1 squared is not 2, 1 squared is 1, 4, 9, 16. And we times the numbers here by the probabilities there, which gives us, and I will skip ahead a bit, all of this, and that equals 0.003. So now we do 0.0003, 0.001 squared, and that gives us, if we round it to the fourth decimal place, 0.0003. So you're taking the negative number is so insignificant it doesn't change much at the fourth decimal place. Now we find sigma, so we know v of x is equal to sigma squared. Sigma is equal to root of 0.0003, and that gives us 0.0173. Now this is a trickier version of a discrete random variable question that comes up a lot in exams, so I encourage you to try this first and problem solve your way through it, and I'll go do it after. Okay, so a discrete random variable x can be either 4, 8, 12, 16, or 20. Probability of that happening is equal to k of x. Find k. Let's draw a probability distribution. X can be, as said, 4, 8, 12, 16, 20. And probability of x, of that event happening, or of the outcome happening, is kx. So right now, x is 4, so that means it is 4k, then 8k, 12k, 16k, and 20k. Now, one important thing to always remember is all of these values should add up to 1. And this is something you should check when you do this question and you're finding it a bit tricky, just to make sure you haven't lost the mark on that. So that means if we add all of these up, 4k plus 8k plus 12k plus 16k plus 20k would equal 1. So that means 60k equals 1. So k is equal to 1 over 60. And you can replace k into the 4k, 8k, 12k and get the values there. And then after that, you go on to finding E of x, V of x, and sigma. Last thing to mention is theoretical versus experimental probability distribution. So for the theoretical one, this is for tossing a coin 3 times. And this is what we got. This was the very first question, and this is the theoretical probability distribution. But it could be if you done the test 10 times and you noted it down, you would see that you might get this probability distribution, where it was apparently more likely to get 0 heads and more likely to get 2 heads compared to the theoretical one. And as you go on to learn more about stats, you'll look at a chi-squared test, and with that you can see, is there a significant difference in these two results? If there is, you can maybe suspect that a coin that was used was weighted or somehow different, and had an influence over the results. That's the end of the video. So by the end of this lesson, you should be able to draw a probability distribution of a discrete random variable. You should be able to calculate E of x, V of x, and sigma. You should be able to use the two formulas down there. You should be able to find k and find the probability of an outcome as well. And you should be able to compare both experimental and theoretical probability distributions. But this is looked on more during the chi-square test.